Hello, so I'm gonna show you what I meant by using UV pins instead of motion paths. So first off, what I'm gonna do here is explain to you what I'm about to do. So when you have a path, a motion path or any type of curve, the curve has a length, but it doesn't have a width. And in order to find an up vector from an object, you need 3 points. So you can, from those 3 points, find the one direction that is perpendicular. If you only have 2 points, so if you have 2 points in a line, every other point around it that is not directly in the path of the line is perpendicular to your line. That's why the flipping occurs, because you can't really calculate an up vector consistently from a curve, which is also why the motion path non-flick option doesn't really work all that well. What we're gonna do is we're gonna use the surface of your street, which has a normal. Every polygon has a normal which is automatically calculated from its vertices. And we're gonna use that normal direction as the up direction of our object. That way it should be way more robust and there should be no flipping. I'm gonna delete your setup so far, except from the joints. So I'm deleting the paths and the locators. And then I'm gonna select the street. I'm going into the rigging menu set. I'm going to constraint and then matrix constraints UV pin, and I'm clicking on the option box. The option box, you should have those settings in there. So your pin location should be transforms, which means that it will put the default pins next to where your joints are right now. And your output should be existing transforms, which will automatically pin the joint directly to your surface. If you don't want that, you could also use new locator, which would then generate locators for you that you could parent constrain to or parent to whatever you want. But since you had a direct parent constraint, I don't see a reason why you shouldn't just use the joint itself. So I'm gonna keep it on existing transform, and then I'm gonna quickly check in the modeling menu set how your UV set is called, and it's called map 1, which is the default. So down here you need to put map 1, which I already have because map 1 is just the default map name. I also use normalize isoparms, even though this is not that important in this case. So then I'm gonna select my joints. So I select the street and select my joints, and then I hit apply. Now nothing seems to have happened, but that's exactly what you want. You don't want anything to flip around or switch or so. But if we go now to our joints, in the channel box we can see there's an input that's called UV pin 1, which is the UV pin constraint. And if we go to the attribute editor, we can see that the offset parent matrix has incoming connections to it, which come from the UV pin constraint, which calculates the UV positions of the street's UV map in world space and then gives them to our joints here. If I were to deform the street, the joints will follow now, which is what you usually use UV pin constraints for, but you can also use them like motion paths. So here on the UV pin, as you can see, for each object that we pinned, we have coordinate values. So coordinate 0 is for our joint 1 and coordinate 1 is for our joint 2. And if I change those coordinates, I can change your position on the street. So what I'm gonna do here, I'm gonna copy this tab because I want these values to go to my controller later. And then I'm gonna create my controller and create some attributes to control this, because I don't want to control the UV pin directly, since you shouldn't have a non-DAG object to control your things, because if you don't have it as a graph in your viewport, it's easy to lose and it's very frustrating to animate with. So I'm creating a NURB circle. Since your scene is so big, I'm gonna put the values to 10,000 in the scales, so I just can see it, and I'm gonna add some attributes. I'm going to add attribute. I'm gonna add 4 float attributes, call them J1U, then J1V, J2U, and J2V. So those are our attributes that will control the U and the V value of our coordinates here. I'm gonna quickly copy over the U and V values from my pin to my controller object. Okay, so they correspond now. Then I can close my tab here again. Now I want to connect the NURB circles U and V attributes to the U and V attributes of our UV pin. So for that, I'm gonna select my circle, go to General, Editors, Connection Editor. As you can see, it loaded my NURB circle in on the left by default, and then it also down here all the way at the bottom are our custom attributes that we created. Now I want the UV pin, so I'm gonna select my street, go to the attribute editor, go to UV pin 1, and then select, and then I reload it on the right. So now I'm gonna select my J1U attribute, and I'm going to coordinates, expand it, expand coordinate 0, and then connect it to coordinate 0, coordinate U. Same with V, and then with the second join, I'm just gonna expand the coordinate 1 attribute and do the same. Now, as you can see, our joints are no longer where they're supposed to be. They are now at the world origin. The reason for this is quite simple. One of the values we have here is either rounded up or rounded down, so it's outside of the UV map. So I just need to quickly open my UVs and check which one it is and in which direction I need to change it. So I open the UV editor, and here we have our UVs. I can see that the U values are all between a little bit more than 1 and a little bit less than 1.7. So it's not the U values, because the U values are 1.3 and 1.4. And then I look down here, the lowest point is minus 2.4 and a little bit. So that means if I look at my values over here, that means that the V values need to be too big. So I'm just gonna change the 7 to a 6 on both V values, the last 7 to a 6. And as you can see, our joints are at the right position again. Well, they're not quite at the right position though, because if you look at it, they're a little bit too low. So I'm just gonna go to 2766, which will round it out again to 277, but it is more exact and it is within the confines of your street. So now we know that this is the value we want to start at, and we can go and set a keyframe for these values. So I'm selecting these, right click, key selected. Then I'm going like 40 frames forward. And now I want to find the V values for the very end of my street, which, if I remember correctly, was something around minus 2.4. So I'm setting them to minus 2.4, which puts them quite close to the end. But they're probably, from what I've seen in the UV editor, not totally at the end. So I'm gonna go to minus 2.41, which reset it, so that's too high. So minus 2.405, which is right at the edge. And I do that for both. 05. And then once again, I key my U and V values. Key selected. Now if I play my animation, so you can see the joints follow the street. And if I select the joints so I can see the way it looks up, the x-axis is always perpendicular to our street. So yeah, that's how you do this. That's how you use a UV pin constraint to drive objects along a surface or a geometry. I hope it helped. If you have any more questions, don't hesitate to ask. Have a nice day.